Welcome back, students. Welcome to the series of lectures on matrices. In the last class we saw about solving a system of linear equations. What we saw in the previous class is that solving a system is equivalent to solving the corresponding row reduced system, and we found that these two systems have got the same set of solutions. We saw some examples. In fact, we saw systems which have a unique solution. Now, let us do some examples where there are no solutions. Let us begin with an example: 2x minus 4y plus z equal to 3, x minus 3y plus z equal to 5, 3x minus 7y plus 2z equal to 12. Fine. So, now let us write down the matrix form of this: 2 minus 4 1, 1 minus 3 1, 3 minus 7 2. When applied on the matrix x y z, when applied on the unknowns x y z, should give me 3 5 and 12. Fine. The augmented matrix for this is 2 1 3 minus 4 minus 3 minus 7 1 1 2 augmented with 3 5 12. We have this is the augmented matrix. Now, we will have to look, we are the non-zero, there are no non-zero rows, and so looking for the first non-zero term in the first row, it is just 2. So, multiply it by half. So, replace R 1 by half times R 1. So, which is going to give me 1 minus 2 half, and then I will have 3 by 2. The other rows are untouched: 1 minus 3 1, 5, 3 minus 7 2, 12, and then I will have to make the other things 0, other elements of the first column into 0. So, replace R 2 by R 2 minus R 1 and replace R 3 by R 3 minus 3 times R 1. I will have 1 0 0. Now, first column is untouched, first row is untouched. Similarly, I will have 3 by 2. For the second one, R 2 minus R 1. So, minus 3 minus minus 2. So, I will have minus 1, and similarly 1 minus half, which is again half, 5 minus 3 by 2, which is 7 by 2, R 3. So, R 3 minus 3 times minus 7 minus minus 6, which is just 1, and similarly I have R 3 minus 3 times. So, 2 minus 3 by 2, which is half. So, I have a minus 1 over here. Fine. And finally, 12 minus 9 by 2, right. I have 12 minus 9 by 2. So, which is 24 minus 9, right. I 3 R 3 minus 3 times R 1. So, 12 minus 3 by minus 3 times 3 by 2, which is 9 by 2. So, 24 minus 9, which is 15 by 2. Right, I have this. Now, this is the second one I have. The first non-zero element in the second one is minus 1. So, let me just multiply it by minus 1. R 2 is replaced by minus of R 2. What I will have is 1 0 0, minus 2 half 3 by 2, 1 minus half minus 7 by 2, and then I have minus 1 half, and then it is going to be 15 by 2. Now, I will have to convert these two into 0, minus 2 and minus 1 into 0. So, replace R 1 by R 1 plus 2 times R 2 and replace R 3 by R 3 plus R 2, and one can notice in this stage that what you have is 1 0, right, this goes to 0. So, R 1 plus 2 times, so half minus 1 which is minus half you have here, this row is untouched 0 1 minus half, but then it is just for the last one what we have is R 3 plus R 1. So, you will have 0 0 0. Now, here the second one is untouched 7 by 2 minus 7 by 2, R 1 plus 2 times R 2, R 1 3 by 2 plus 2 times R 2. So, 2 times of that is so minus of 14 by 2. So, what you will have is minus 11 by 2, and similarly R 3 plus R 1 15 by 2 minus 7 by 2. So, I will have 8 by, which is just 4. But what you can notice here is that the last row, in the last row of the coefficient matrix you have just only zeros, but on the other hand what you have is a non-zero term over here. If you just convert this back into the system of linear equations, what you will have is the following: x minus z by 2 equal to minus 11 by 2, y minus z by 2 equal to minus 7 by 2, 0 times x, sorry, 0 times z, 0 times x plus 0 times y plus 0 times z equal to 4. So, this system has got no solution, right, because this last one does not make sense. What it says is that 0 equal to 4. Therefore, the given system has no solution. Let us write down again the last obtained last resultant matrix. What we had is 1 0 0, 0 1 0, minus half 0, minus 11 by 2, minus 7 by 2, 8 by 2, right. So, this is the rank of this coefficient matrix. By looking at this, one can easily conclude that the rank of the coefficient matrix A is just 2, while rank of the augmented matrix is 3, and we know that 2 is strictly less than 3. This implies that the system has no solution. What we wanted for the solution to exist is that rank of A should be equal to the rank of the augmented matrix, but that is not the case here, which can be easily observed. Now, let us do one more example. Solve the system one plus I into z1 minus z2 equal to I, 1 minus I into z1 plus 1 plus I into z2 equal to 1. Notice that this is a system with complex coefficients. Well, the procedure is the same. So, let us apply the same algorithm to reduce the coefficient matrix into its row reduced form. So, the augmented matrix is given as follows: 1 by 1 plus I minus 1, 1 minus I, 1 plus I augmented with I and 1. So, you have the first term as 1 plus I. Let us convert this 1 plus I into 1. R 1 is replaced by 1 by 1 plus I into R 1, which is 1 minus 1 by 1 plus I by 1 plus I, 1 minus I, 1 plus I, 1. So, now let us write down the resulting matrix. 1, next one is minus 1 by 1 plus I. Let us multiply and divide by 1 minus I. So, what we will end up with is, on the numerator you will have minus 1 plus I upon 1 plus I into 1 minus I, which will lead to 2 augmented with I into 1 minus I, which is minus 1 plus I upon 2, and then 1 minus I, 1 plus I, 1. So, next I have this 1 minus I. Let me convert this 1 minus I into 0. R 2 is replaced by R 2 minus 1 minus I into R 1. So, what I will end up with, the first row leads to 1 0, and similarly the first row remains the same. You will have minus 1 plus I upon 2 and augmented with minus 1 plus I upon 2. Sorry, it is going to be 1 plus I upon 2. Yeah, even in the previous one it is just 1 plus I upon 2. Upon 2. Now, let us calculate the remaining terms. It is 1 plus I minus 1 minus I into minus 1 plus I, which is same as 1 plus I plus 1 minus I whole square, but 1 minus I whole square is exactly 2, sorry, it is minus 2. So, you will have, sorry, it is what we will have. So, we will have 1 plus I plus 1 minus I whole square upon 2, which will lead to 1 plus I plus 1 minus 2 I plus 1 minus 2 I minus 1 whole upon 2. So, this 1 gets cancelled and you will have minus 2 I, and so this minus 2 I and 2 gets 2 and 2 gets cancelled. Therefore, you will have 1 plus I minus I. So, you will finally end up with just 1. Next one, 1 minus I into 1 plus I upon 2, 1 minus I into 1 plus I is just 2, and so this gets cancelled. You will have 1 minus 1, which will leave to 0. Now, I have 1 over here. Let me convert this other element in the second column, that is minus 1 plus I upon 2 to 0. R 1 is replaced by R 1 minus 1 plus I upon 2 into R 2. I will have 1 0 0 1. I am just adding something with 0. So, which will essentially lead to the same thing, 1 plus I upon 2 and then a 0, right. So, therefore, what do we have? Z 1 is 1 plus I upon 2 and Z 2 is 0. Thus, the solution is 1 plus I upon 2 and 0 is the solution. Consider the system 2x plus 5y plus 2z equal to minus 1, x plus 2y minus 3z equal to 5, 5x plus 12y plus z equal to 10. As usual, let us write down in the matrix form 2 1 5, 5 2 12, 2 minus 3 1, times the unknowns x, y, z. So, the constant matrix or the constant term matrix is 1, 5, 10, right. We have written the given system in terms of matrices. Now, let us write down the augmented matrix A augmented with the constant term matrix B. The coefficient matrix is just 2, 1, 5, 5, 2, 12, 2, minus 3, 1, and we are augmenting with the constant term matrix which is minus 1, 5 and 10. We have no non-zero rows, no 0 rows, and therefore, we look for the first non-zero term in the first row which is just 2. So, our aim now is to convert this 2 into 1. So, we replace R 1 by half of R 1 which is going to give me 1, 5 by 2, 1 augmented with minus half. The remaining rows are untouched 1, 2, minus 3, 5, 5, 12, 1 and 10. I have this. Now, I will have to make the other things 0, that is 1 and 5 into 0. Replace R 2 by R 2 minus R 1 and replace R 3 by R 3 minus 5 times R 1. First row remains untouched 1, 5 by 2, 1 and then you have minus half. So, 1 minus 1 which is 0, 2 minus 5 by 2 which is 5 by 2, minus 3 minus 1 which will give me minus 4, right, 5 minus half which is 5 plus half, 5 plus half, 11 by 2, right. And now here it is 0, it is 12 minus 5 times the R 1, 12 minus 5 times R 1 which is 5 into 5, 25 by 2. So, I will have minus half 1 minus 5 which will give me minus 4. R 2 minus, sorry, this is not the second element is R 2 minus R 1, 2 minus 5 by 2, oh, this is minus half, that is exactly what I wanted. Here it is going to be R 3 10 minus 5 times minus half which is going to give me 10 plus 5 by 2 which is 25 by 2. Fine. Now, let me just convert this thing into 1. R 2 is replaced by minus half times R 2. What I will have is 1 0 0, 5 by 2 1 minus half. I am just multiplying it by minus 2. So, I will have 1 which is 8 here minus 11 and then the remaining stays as it is which are unchanged. I will have to convert the other two elements into 0 which is 5 by 2 and minus half. So, what I will do is replace R 1 by R 1 minus 5 by 2 times R 1 and similarly R 3 is replaced by R 3 minus plus half times R 2. So, the resulting matrix is, you will notice that 1 0 0, 0 1 0 and then the last terms are, it is going to be 8 which is going to remain untouched. The first one which is R 1 which is 1 minus R 1 minus 5 by 2 times R 2, 5 by 2 times R 2 which is 8, 4, 20. So, 1 minus 20 which will give me minus 19. Here it is going to be 0 and the augmented matrix is going to be, I will have minus half minus 5 by 2 times minus 11 minus 55. So, I will have minus 54 by 2. I am least bother about what the original one, and this is minus 11, and finally, I will have 25 by 2 plus half times minus 11. So, which will give me 14 by 2. This is the one that I have. Now, the rank of the coefficient matrix A, just look at this and one can easily conclude that it is just 2, and similarly rank of the augmented matrix, which in this case is you have, although you have a non-zero 0 row, you have this non-zero term which will easily tell us that this is going to be 3. Therefore, rank of the augmented matrix is strictly greater than the rank of the coefficient matrix. That will imply that the given system has no solution. Now, let us do one more example. Let us try to do one more example. X plus 3y plus 4z equal to 11, 2x plus 3y plus 2z equal to 7, 4x plus 9y plus 10z equal to 20, and finally 3x minus 2y plus z equal to 1. This is the system that I have. Again, one can notice that this is an overdetermined system. That means, the number of unknowns in this case is 3, while the number of equations in this case is 4. So, this is an overdetermined system, fine. Now, let us try to write down in the form of matrix 1, 2, 4, 3, 3, 3, 9, minus 2, 4, 2, 10, 1, when applied on the coefficient on the unknowns x, y, z should give me the constant matrix, constant vector 11, 7, 20 and 1. As usual, let us write down the augmented matrix. For this, the augmented matrix is 1, 2, 4, 3, 3, 3, 9 minus 2, 4, 2, 10, 1, augmented with 11, 7, 20 and 1. This is the system that we have. This is the augmented matrix. Now, let us try to write down the, so do the row elementary operations. Notice that there are no 0 rows, and therefore, the first row, look for the first row, it has got a, the first non-zero element is 1. So, we do not have anything to be done. We will convert the other elements into of that column into zeros, replace R 2 by R 2 minus 2 times R 1, R 3 is replaced by R 3 minus 4 times R 1, R 4 is replaced by R 4 minus 3 times R 1. Let us perform all these operations. So, as a resultant what we expect is that all these 3 goes to 0, fine, and then 3 remains as it is. The first row in fact whole remains unchanged. R 2 is replaced by 2 times R 1. So, 3 minus 6, which is minus 3, 2 minus 2 times 4. So, you will again have minus 6, 7 minus 2 times 11. So, 7 minus 22, which is minus 15, and then 9 minus 4 times 3, which is 9 minus 12, you will have minus 3, 10 minus 16, I will have minus 6, and then 20 minus 44, yes, 20 minus 44, which will give me minus 24. The last one, minus 2 minus 9, which is minus 11, 1 minus 12, which is minus 11, 1 minus 33, which is minus 32. Right. The second row, the first non-zero coefficient is minus 3. Let us make it into 1. R 2 is replaced by 1 by minus 3 times R 2. I will have 1 0 0 0, 3 4 augmented with 11, which is 1 minus 2, I will have 5, the other things are untouched. So, my next aim is to convert this 3, minus 3 and minus 11 into zeros. So, replace R 1 by R 1 minus 3 times R 2, replace R 3 by R 3 plus 3 times R 2, and replace R 4 by R 4 plus 11 times R 2. Well, let us do these operations. The first column is going to be 1 0 0 0, the second one turns out to be 0 1 0 0, third one let us calculate. R 1 is replaced by R 1 minus, so 4 minus 6, which is minus 2, augmented with 11 minus 15, which is minus 4, second row remains as it is 2 5, third one R 3 minus 6 plus 3 times R 2, which will give me 0, minus 24 plus 15, which will give me minus 9, and then I have R 4. So, minus 11 plus 22, you have 11, minus 32 plus 35, so which will give me just 3. I have a 0 row in between, right. I do not have, so no, the next one is that I have a 0 row. So, interchange R 3 is swapped with R 4, I have 1 0 minus 2 with minus 4 0 1 2 5 0 0 11 3 0 0 0 minus 9. Convert this 11 into 1, but I do not have to do that because I have a 0 row over here and a non-zero term over here, right. Therefore, the system has got no solution. Because you have a non-zero row in the coefficient matrix, but while in the augmented matrix you have a non-zero term, and therefore, this system has got no solution. Let us proceed further with examples. Now, let us do some examples wherein you have infinite number of solutions, right. Our first example, let us look for an easy, let us begin with an easy example. X plus 2y plus 3t equal to 7, z plus 4t equal to, one can notice that this is an underdetermined system. That means what? Let us look at the number of unknowns or the number of variables that we have is 4. Well, the number of equations that we have in this case is just through 2. So, 2 is strictly less than 4, therefore, this is an underdetermined system. Let us try to solve this. Let us before that first let as usual write down the matrix form of this 1 2 0 3 0 0 1 4 evaluated at x y z t equal to 7 and 8. Fine. Now, notice that in this case the given matrix or the given coefficient matrix is itself in the row reduced form, because the first non-zero coefficient is 1 and the other elements in that column is 0, and you have there are only 2 equations, in fact 2 rows. So, the other one is 0, and similarly the first non-zero element appears in the third column and the other element is 0, therefore, this is a row reduced echelon. Now, how to solve this system? What are the solutions for this system, right? So, wherever there is 1 and zeros, right, we will call these the variables corresponding to these positions, right. So, this I will call it as the corresponding to 1 and 3. So, the variables x and z are dependent variables while the other variables, that is variables y and t are independent variables. So, wherever there is an independent variable, so let us try to, so we have 2 independent variables. So, let me say that y is lambda and t is mu, where lambda and mu or any real numbers or any real numbers or any arbitrary real numbers, right. Now, let us write down again, let us look at the write down the equation x plus 2y plus 3t equal to 7, z plus 4t equal to 8. Now, just substitute y equal to lambda and t equal to mu and then see what is there. X plus 2 lambda plus 3t equal to 7, lambda plus 4t equal to 8. Sorry, it should be the other way, right, sorry. It should be z plus 4 mu, z plus 4 mu is 8. So, the second one, so this will imply that z is 8 minus 4 mu. Just substitute in the first one, what will I have? So, 2 lambda plus 3 mu. So, what will I have? X equal to 7 minus 2 lambda minus 3 mu, right. The second one gives z as 8 minus 4 mu, first one gives x as 7 minus 2 lambda minus 3 mu. So, therefore, the solution set to this equation 7 minus 2 lambda minus 3 mu comma lambda comma 8 minus 4 mu comma mu, with the condition that lambda and mu both are from real numbers. So, we have an infinite number of solutions for various lambda and mu, you get various solutions. For each lambda and mu you get various different solution, right. As lambda and mu varies, the solution keeps changing. That is what we observed through this example. Let us do one more example. 8x plus 5y plus 11z equal to 30 minus x minus 4y plus 2z equal to 3, 2x minus y plus 5z equal to 2. Let us write down the matrix form 8, 5, 11, minus 1, minus 4, 2, 2, minus 1, 5. When this is applied on the unknown vector x, y, z, should give me 33 and 12. So, the augmented matrix in this case is 8 minus 1 2, 5 minus 4 minus 1, 11 2 5 augmented with 33 and 12. So, there are as usual there are no 0 rows. So, let us convert the first one, R 1 is replaced by 1 by 8 times R 1. What we will have is 1, 5 by 8, 11 by 8, 30 by 8. The other rows are unchanged, minus 1, minus 4, 2, 3, 2, minus 1, 5 and 12. We will have to convert the other rows, other elements of the first column into 0. R 2 is replaced by R 2 plus R 1 and R 3 is replaced by R 3 minus 2 times R 1. The first column becomes 1 0 0, right. Minus 4 plus 5 by 8, 4 plus 5 by 8 minus 32 plus 5 you will have. So, first column as usual remains unchanged, let us write it down. Minus 27 by 8 2 plus 11 by 8. So, 16 plus 11. So, 27 by 8 and then R 3 minus 1 minus 2 times minus 4. So, which is 8 minus 1 7, 5 minus 2 times 2, 5 minus 4 which is 1, you have 12 minus 2 times 3. So, 12 minus 6 which is, oh, I have 6, okay. No. What am I trying for? This is wrong. So, let us convert the first element. R1 is replaced by 1 by 8 times R1. What will I have? 1, 5 by 8, 11 by 8 and then it is augmented with 30 by 8, minus 1, minus 4, 2, 3, 2 minus 1, 5 and 12. I will have to convert these two elements into 0. So, I am just replacing R2 by R2 plus R1 and R3 is replaced by R3 minus 2 times R1. First row remains unchanged, 1, 5 by 8, 11 by 8 and I will have 30 by 8, 0. So, I will have minus 4 plus 5 by 8 which will give me 27 by 8, 2 plus 11 by 8 which is again 27 by 8. So, you have a minus minus 27 by 8. So, here you will have 27 by 8, right, and then I will have minus 1 plus 2 times 5 by 8. So, I will have 5 by 4. So, minus 1 plus 5 by 4 I will have 0, sorry, minus 4 plus 5. So, this is 0. So, minus 1 minus 4. So, I will have 1 by 4 and then 5 minus 2 times 11 by 8 which will give me 5 minus 11 by 4 which is 20 minus 11 by 4. So, I will have 9 by 4. So, these terms 3 into 3 plus 30 by 8, 24 plus 30, 54 by 8 and then finally, I will have 12 minus 2 times 30 by 8 which is 12 minus 30 by 4. So, 48 minus 30 which is 18 by 4. Now, the next element is just 20, so this one I will have to make it into 1. Replace R2 by minus 8 by 27 times R2, 1 0 0, the other rows are untouched. I will just have 1 by 4, 9 by 4, 18 by 4. Fine. Now, if I multiply, this will become just 1, the remaining term I will have 20. So, I will have minus 1, I will have minus 2, have minus 2. Now, I will have to convert the other elements of the second column into 0. So, replace R 1 by R 1 minus 5 by 8 times R 2 and replace R 3 by R 3 minus 1 by 4 times R 2. What will I have? The first column remains unchanged, the second column turns out to be 0 1 0 and for the third column, if I convert this, so what will I have? The first one is replaced by, is it 9 by 4 or 1 by 4, there is small change. This should not be 9 by 4, this should be 1 by 4, R 3 by 2 times R 1. So, you will have 11 by 4, 5 minus 11 by 4, so 20 minus 9, sorry 9 by 4. This term R 3 is just minus 1 plus 2 into 5 by 4 minus 1. Fine, okay. Let's have it as it is. 0 0 0 1 0 0 and then I will have this term is, so R 1 is 11 by 8 minus 5 by 8 times minus 1, which I will have it as 16 by 5, sorry 16 by 8, and then this minus 1 remains as it is, 9 by 4 minus 1 by 4 into minus 1 . So, which is going to be 10 by 4 augmented with R 1. So, 30 by 8 minus 5 by 8 into minus 2. So, I will have 40 by 8 and then the second one remains as it is, minus 2. The last one, it is going to be 18 by 4 minus 1 by 4 into minus 2. So, which is going to be 20 by 4. Fine. Now, I will have to convert this element into 1. So, replace R 3 by 4 by 10 times R 3 . The other rows remains unchanged, 0 1 minus 1 2 0 0 1, 4 by 10 I will have just 2. Convert the other elements into 0, these two. So, R 2 is replaced by R2 plus R3, R1 is replaced by R1 minus 16 by 8 into R3. First and second column remains unchanged. And the last one, this one. R2 is replaced by R2 plus R3. I will have a 0, this plus this, which is going to give me 0. And then these two things, R1 is replaced by, which is 16 by 8 minus, this term is again 0, but then I will have, which is 40 by 8 minus 16 by 8 into 2. So, this is 32. So, which is 8 by 8, which is 1. Here you have a definite solution. The solution in this case is, the rank is 3, right. Solution you have 1, 0 and 2 is the solution. The solution is unique in this case. In the next lectures, we will do some more examples, wherein you will have examples with for overdetermined systems, underdetermined systems, multiple solutions and all these things. Thank you all.